Okay, guys, let's get started. So we're almost there. We're almost done with syllabus. We just have a few more things to do, which should be done by the next session. I hope. Let's see how it goes. Okay, depends on you guys as well. How much you want to do, whether we get tired or not. We'll see how that goes. Okay, so the last time I saw you guys, we looked at something called logical equivalence for truth tables. Right? Again, just quick summary, logical equivalence between two statements means that the outputs on the truth table are exactly the same. So here, for example, the two things right at the end, so we're checking the truth table values are exactly the same. They match false for false, true for true. They match exactly. If you get perfect matches like that, we can say that the two statements are logically equivalent. So that's the last thing we did the last time. I think we'll probably look at more examples. Yeah, we will today. Another logical equivalence example, which is good because we probably were all a bit tired when we reached that last one. Right, so let's look at the quality of this one. Are these two statements logically equivalent? Again, this is a typical type of question you will be given in these truth table sections. All right, so let's start with this one here. Are the statements logically equivalent? So do you guys want to try this before I do it? Anybody? Yeah. Okay, I'll give you guys a moment. Give it a try. This thing so sensitive today.
You wrote that, so you said you like big cloud. You wrote that, that was not perfect. Is that a good that was new like? But I like the one, but it is. I was also, no, it's not a time. That happened. It's not. That's the cover. Yeah. Yeah. Like the 337. Oh, really? So I just reached this. Oh, yeah. No.
Guys, please keep all phone volumes down. People are trying to work.
We're waiting for it's funny. This was always partially that's all once but more like let's go. On himself watching what can I do? Yeah. Here, good one. One is before. Okay, so if we take it to that, now if we take it to that, if not to okay, we need to decide the next. You want before.
Hey guys, anyone needs more time? Anyone's still busy? Okay, so let's get started with this example. If you guys are comfortable and you know how to do this already, you don't have to stress about what I'm saying. If you need the help, pay attention because we're reaching, I think this is the last example for truth tables that we do. Okay, actually we do a few more, but in a slightly different context. So this is the last pure truth table example. So if you need the help, pay attention here. Okay, so as always, we will start constructing the truth table by breaking every statement down into as simple statements as we can. Right, so we see here, we're looking at two statements, and all of them are made up of Q and R. Right, there's three statements here, which makes everything up. So we'll start in that way by stating P, Q, and R. P, Q, R, that's the simplest we can go. The next thing we will need, if I'm looking at the first statement, we will need a P and Q. No, sorry, that's a POQ. It's a downward triangle. So we'll need a POQ at some point. We'll need a if P, then R. We'll also need if Q, then R. We will then need, then we can do the final statements. The first one ends up being P or Q in the first part of an if-then statement. R is the second part. And the last one, I'll just take it down exactly as it is. This is quite a lengthy example with an or between Q, R. Okay, so again, if your setup is not exactly the same order I did it, that's okay, as long as you have all the elements at some point. So increment this. And you guys may remember the number of rows that rows top to bottom? Yeah, the number of rows that I use, it goes with the number of variables. So because we have three primary variables here, it's 2 to the power 3 rows, which is 8 rows. So I'll make 8 rows here. Okay, and remember when setting these up, the P, Q, and R, the primary variables always just need to have every possible combination of true and false that you can get. So there's a set way to do this. I mean, you can do this any number of ways, but the way we do it is, as I've shown you guys the last time, for the P, I'm just going to divide this part, the column, into half and make half true, half false. Then the next one, I divide into quarters, and I'll make the first quarter true, second one false, third one true, fourth one false. Then for the R, we just increment everything. True, false, true, false. So we divide into 8, basically. True, false, and just keep going. Okay. So that gives us every possible combination of true and false that we can get for 3 variables. All right. So I'm changing color because here we're actually putting in the answers. Now everything else was standard up to this point. Now we fill in answers. Okay, so what's the truth value between, or the rule for truth value between P or Q is that P or Q need to be true, right, for the statement to be true. So I look at the P, Q column, and if I find anything true there, it means that this entry is going to be true, right? So first row, between P and Q, is anything true? Yes, both are true, so that's true. Second row, same story. Third row, P is true, so that's good enough. Fourth row, P is true, so good enough. Fifth row, Q is true, so good enough. Same story in the sixth row. Seventh row, nothing is true between P and Q, so we say false here. And the same is true of the last row. Nothing is true between P and Q, so we have to say false. Okay, so these ones are not too bad, but the if-then statements become a little bit confusing. So to do that, let's change color. I'll do the trick we did the last time, where we write the statement above the variables. We'll write the condition above the variables. Why is this thing so sensitive? Okay. So for if P then, we're working with P and R, sorry. If P then R, we need, for this to be true, we need P to be false or R to be true. So I'll just write that above the variables themselves. You need P to be false or R to be true. If any of those are met, then it's good enough to say the statement is true. Right, so all I'll do is I'll go down row by row and check if I match what I've written above. That's the easiest way to do this. So the first row, do I match any of the conditions I've written above? Yes, I match it here with the R, right? There's a true there and there's a true at the top. The P doesn't match, right? The P has a true, but we need a false. Okay, so second row, let's check if we match anything. I don't see any matches there, so I'll leave that out. Third row, do we match? Yes, we match here by the R. Fourth row, I don't see a match. Fifth row, I see a double match. Sixth row, there's a match by the P. Seventh row, we have a match again by the P and by the R, actually, both match. And last row, we have a match by the P. So I'm just checking where I find a match. And if I found a match in that row, it's good enough to say the statement is true. So everywhere I've drawn a circle, I'll say true. Everything else must be false. False, false, false. That's probably the easiest way to do these things. Now we can do the same thing again for the if Q then R statement. I'll change color for that. Let's use red again. Why not? Okay, so the condition is always the same. For the if Q then R, I need the first statement to be false. So I'll write that above the first statement. Or the second statement needs to be true. Those are the conditions we need to meet. So I'll just go down the rows and check where I meet the condition. So again, we need Q to be false or R to be true. Let's see, in the first row, do I meet that? I meet that here with the R. The Q is not met. Okay. Second row, do we meet this anywhere? No, we don't. Make sure I'm looking at the red now. It doesn't matter because they're both the same. But yeah, make sure you're looking at the red. That's important. Third row, do we meet anywhere? Yes, we do. Okay, guys, a little bit quieter, please. We actually meet the Q as well, so we have a double match here. Fourth row, do we meet anywhere? Yes, we do. We meet for the Q. Fifth row, we meet for the R. Sixth row, don't meet anywhere. Seventh, we meet for the R and for the Q. And finally, we meet for the Q in the final row. So I'm doing this a bit slowly to make sure we don't miss anything, because it's easy to mess these up. And anywhere where I've drawn a red circle, that's where I will say true for the statement. So I'll say true here, true here, true here, true here, true and true. Anywhere else is false. Okay, so false, false. Okay, are you guys comfortable with this, or am I like overly explaining it today? It's good. Okay. Okay, now we need to do the same thing again for another if-then statement. Yeah, so let's see. This one goes from a statement itself, a molecular statement, POQ. So, but still, it doesn't change anything. That first part, the POQ part, needs to be false. And the second part needs to be true. So let's change color for that. Running out of options here. Let's make it a gray. Why not? Okay, so again, sorry. Yeah.
For the EROI, right?
Yeah.
Is it like the last one of the day? It's in a false step because one condition is the TV false.
One condition is met.
Last one.
Oh, the last one, sorry. Q and R. So
Yeah.
Second, yeah. So that one is met. Yeah, you're right. You're right.
And similarly for two rows up.
Yeah.
Yeah.
Yeah, you're right. We met one.
Wouldn't it be true under the?
So this should be true.
Yeah.
Yeah, you're right. You're right. I'll correct that. Thank you. Okay. Yeah. So you guys see, it's easy to make mistakes here. So just be careful. Thanks for that, guys. So those two falses should become trues. Now to find the color, this one, I think. True, true. Okay.
Yeah.
All right. Is that good so far?
Yeah.
All right. Everyone else sort of on the same page here? Okay. All right. Let's go back to this weird gray color and do this other one. Okay, so here we need the P and Q, sorry, POQ, which is the first statement. We need that part to be false. So I'm going to put an F up here. And we need the R to be true. Maybe this color is not the best. Let's put a bit of a darker gray. True, false, that's a bit better. Okay. So now again, we go down the columns and find a match. If we find a match, we say true. If we don't find a match, we say false. All right, so first, immediately we find a match here. Second row, we find no matches. These colors are already getting confusing, so I'm going to go slowly. No matches, second column. Third one, we find a match here. Fourth one, I don't see any match. Fifth one, we have a match. Sixth one, no match. Seventh one, match. Double match, actually. Eighth one, match. Okay, so everywhere I've drawn a gray circle, my statement will be true. That's here, 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 and here. And everything else is just false. Okay, it's only these if-then statements that are a bit problematic. The others are really not so bad. Like this last one here shouldn't be too bad. It is just an or between, let's identify the columns though, using another color. We're running out of all the normal colors here. Let's use a green. Okay, so it's an or between, where are we? It's an or between this one here and this one here. Okay, so an or statement is true as long as one of the two things are true. As long as I find it true, I can say true. So first one is true. Okay, then we got false. Then we got true. Guys, please. We have a true here. We have a true, true, true. Yeah. As long as any one of these two is true, or both of them. Yeah. Is that all right? Color is pretty bad color. All right, it looks good on this screen, but on that screen it looks terrible. Can you guys all see that last column? Okay. So now let's just check again. Sometimes we get so lost in the truth table, we forget what we've been asked. We were asked whether the statements, okay, let's take these arrows out so I can identify these statements. We asked whether the statements, let's use black for this one here, and this one here are logically equivalent, which means the truth table values need to match exactly. So are they? Let's check. First one matches, second one matches, third match. There's not a match here. Match, not a match, match, match. So everything has to match to be logically equivalent, because why now? Because we don't get a match for these two, that means they're not logically equivalent. All right. And I suspected we need to get at least one which is not logically equivalent, because so far all we've checked were logically equivalent. So they will give us one which doesn't work. Okay, I'll leave this up for a few seconds for you guys to write, to take pictures or whatever you need to do. Of course, the video will be uploaded as well, so you will get access to this. Yeah. All the stuff. Maybe don't comment. I don't know. I always get hesitant because last year I just stopped telling jokes in class because of, you guys know.
We have watched shows.
Yeah.
Yeah. People begins.
What is an offense? Wow.
Okay, so I'm looking at the slider here. Looks like we're already about halfway done. The next thing we look at are called deductions, which again is just another way to get into truth tables. So a deduction, well, we kind of need something that we learned already for deductions, but anyway, we learn this on the go, right? If we need to go back to the theory, we will. So a deduction, they jump straight to an example. Okay, you know what? Let me go back to the top because you guys need to know this as well. We defined something here which we will need called an argument. Right? So an argument is made up of premises and a conclusion, and we're going to use this here. So an argument is valid if the premises are true at the same time that the conclusion is true. Right? That sounds about right. The premises are true and the conclusion is true. It means the argument is valid. So now we're going to use truth tables to try to see whether arguments are valid or not. So this little diagram here is what we're going to be referring to. Premises and conclusion. Okay, so let's jump straight to that example and check whether this argument is true. Okay, so the argument given is if Edith eats her vegetables, then she can have a cookie. Edith ate her vegetables, therefore Edith gets a cookie. Whole thing is what we're analyzing, right? So first we have to make statements out of this, which they've done for us. The first statement, which they call P, is Edith eats her vegetables. That's P. Then Q is Edith can have a cookie. Okay, so they wrote it in a weird way at the bottom. I'm not sure why. It's better to write it like this. If P, then Q. Is that the first statement? If Edith eats her vegetables, then she can have a cookie, right? That's the first part here we've covered. Then it says Edith ate her vegetables. So which one is that? That's P. So basically P happened. So we write P at the bottom. Edith ate her vegetables. Therefore, Edith gets a cookie. So that's at the bottom here. Therefore, Q is Edith gets a cookie. So this is just making the statement into sort of a mathematical language here. And then from here, we use the truth table to determine whether this is a valid argument or not. right? And we will determine that now based on what we've done above. Let's change color here. These are the premises. How do you spell with an I? Yes, I don't even know. Is that right? And this is the conclusion. I think it's ESIS. I'm doing the wrong thing here. I'm not sure. Who here is sharp in spelling on the spot without autocorrect? Should be right. Okay. All right. So all we need to do here is make a truth table for all these statements here and check if we find a place, find places where all the premises are true and check in that case whether the conclusion is also true. All we need to do, which I think they've done for us, but you know what? We don't need their work. We can do it ourselves. It's an easy one. All right. So let's do it. It's just P, Q, if P, then Q, right? That's all it is. So it's a very simple one. Let's make the thing. We need 1, 2, 3, 4. 1, 2, 3. Right. We'll just put it in here. So that's true, true, false, false, true, false, true, false. And we can fill in the last one. Hopefully in a different color. Why not? So it's true if P is false or Q is true. Let's do our usual method. P false or Q true. Find matches. There's one here. There's one here. Well, there's two here. And there's one here. So that's true, 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 and false. All right, that one's not too difficult to do. Now, do we find a place where the premises are true? Right, the first row. And in that case, is the conclusion also true? Yes, it is. We found a place where that happens. So the premises are here and here, according to what we've labeled above, and the conclusion is here. All three are true at the same time in row 1. So that's good. But we need to check all the cases. We need to find all the cases where the premises are true. That also happens in, it doesn't happen anywhere else, does it? It's just this one place, right? So it only happens in one place. So that means the argument is valid. Okay, so that's how we check these things. First, we have to make the statement above in this form. Then we make a truth table and check whether the premises and conclusion are true at the same time. All right. What's at the top of the line and what's at the bottom need to be true at the same time. So P, Q, and the statement if P, then Q. And we will do some examples here. I won't just leave you guys at that. Let's just make sure they told us the same thing we said. Into true, first two rows. Yeah. Okay. So shall I leave you guys to try another one before I do it? So this is the statement. Well, these are the statements rather. Remember that at the top we have the premises. At the bottom we have the conclusion. I'll give you guys a few moments to try that one.
That's all one. This one is there for. It's supposed to be. And you can that are completely. Oh, yeah, I did. You just give it like a day or two and just play it on. Otherwise, I have to get a lecture. No, yeah, but you. But one that that's very good. But then it's about this, so it's also something false. The next to that's that should go on so that then we see then okay, what it is, but if this is true, this is true, then this is true, and this is true, then it's equal to that. Maybe one is true, if two is true, I'm going to stay with each other. All you need to do is true, as you do it. If you should do what the second do that. That is my just to say there, and it's not this, yeah. The balance. So here is true, but if you speak that it's all of the new time. At least that's the you. Yeah. If any design here is that would be. I mean, your relationship with people, just yeah, that together on this this is true. Honest because we should just get such a show. No, I think one.
Okay, so guys, I'm going to do the solution on the board. If you're still busy, that's okay. I'm going to do it quietly. If you need to ask anything, please interrupt me. Okay, so guys, I'll give you a moment, just verify whether you have the same truth table as I do. Then I'll explain how to go further from there. Okay. You guys got the same thing. Working together. Good. Okay, so once we have this, then we need to check the places where the premises are true. And the premises here are this and this. So where are they both true? That happens to be here and here. Now, which of these cases, let's see. Now, if we find places where the premises are true, then we must have the conclusion true as well. So the first one doesn't work. No, it does, sorry, I'm looking at the wrong variable. It does. Because here the conclusion is, okay, guys, please, let's keep it down a little bit more. What's happening? Change color to green. So first row, the premises are true. Is the conclusion true? Yes, it is. Third row, premises are true. Conclusion is also true. So whenever premises are true, conclusion is true. So that means the deduction rule is valid. All right. If we happen to see, for example, here, third row that Q was false, then it wouldn't work. We would say deduction rule is not valid. Okay. All right. So this is a bit of a longer one. You guys want to take the break at this point?
Yes.
15 minutes plus 2 minutes since we rounding down. Yeah, that's the last thing. I don't think I've ever seen a proof come out in